Hey, what's up guys? Welcome back to the next video. So in today's video, I'm going to show you 3 ways of writing a program for checking whether a number is prime or not. So basically you might have seen the algorithm before also and you might have not understood properly. So please see this video completely. I'm going to show you 3 ways, 3 different ways, and each will be having its unique code. Okay, so basically they will be differing in terms of number of iterations and execution time. So as the algorithm complexity increases, the runtime will reduce. So first I will explain you one by one. Let me just take a pen over here. So let me just take our number, guys. Okay, so I'll just take 3. Okay, so 3, and here I'm having another number 4, and I'm having another number let us say 6. Okay, 3 examples I will take. Just listen carefully. Okay, so once you understand this thing like the algorithm, then writing code is a piece of cake. So first 3 means what are all the factors? Don't forget about prime factors. Okay, so just generally if you discuss what will be the factors of 3. So the first one will be 1. It is a factor of 3. After that 3 will be the factor of 3 itself. Okay, so factor means it should be completely divisible by the number 3 divided by any number I, which gives remainder equal to 0 will be called as the factor. So I will be called as factor. So 3 is having 1 and 3. After that, let us go to the 4, and it will be having 1. 1 is factor for everyone because it can divide any number. So after that it will be having another called 2. 2 can divide 4, and after that you can see 4 will be the last factor. So similarly I'll just check out for 6 as well. So 6, 1 will be the factor, one of the factor. After that 2 will also divide completely 6. After that 3 will also divide the 6 completely, and after that 6 will also divide 6 completely. So these are the factors, guys. Now the important thing is that so this is the first method, guys. Okay, so this is basic one. If you don't want to take much stress, then you can go with this one. Okay, so now when I can say the prime number, so out of these things 3 is prime number. I know this one. Okay, so apparently I know because 3 is a prime number, and 4 and 6 are not prime numbers. So here you can see whenever a particular number says only the particular number will be having only 2 factors. The one will be one factor and the number itself will be another factor. So at that moment I can call as it is a prime number. Okay, so you can take example of 4. You can see the number of factors are greater than 2. So if it is greater than 2, then it's not a prime. If it is exactly equal to 2, I can say it's a prime number. So this is the logic, guys. This is the whole logic. So we need to find out the factors, and if the factors are equal to 2, then I can say it's a prime number. If it is greater than 2 or less than 2, then I can say it's a not a prime number. And you can see for 6 there are 4 factors, and which is obviously greater than 2, and it's not a prime number. And similarly I will take an example of let us say okay, 5 I will take. Okay, so 5, and for 5 1 will be the first prime 1 will be the first factor. After that nothing will be there, and 5 will be the factor, because in between 1 and 5 there are 2, 3, 4, and out of these 3 numbers no one will be dividing 5 completely. So that's why 5 is prime number, because its factors are exactly equal to 2. So this is the logic, guys. This is the method 1. Okay, so now let me go to the VS Code, and I'll just write a code over here. You can just see. Okay, so I will just import one statement. Import java.util.star. Okay, so I will use scanner class to take the input, and before that I will take a main method, and after that scanner sc equal to new scanner, and here I will write system.in. Okay, so this is for taking input from the user. Now let me just print one message saying that enter the number. So here user will enter the number. So after that I will take one integer, let us say capital int n equal to sc dot next int, and here I will write semicolon. So it will take the integer from the user. Now I have to write one loop here. So loop should start from 1, guys. Okay, so for int I is equal to 1 and I should be less than or equal to, so I should be less than or equal to capital N and I plus plus. So it should run up to this, and here I will be taking another count. Let us say int count equal to 0. I will initialize with 0 so that I can check it later. Okay, so here I will write if n modulus I is equal to 0. If it is 0 means it's completely divisible by 2, then count equal to count plus 1. Okay, alright, so that's it, guys, and we have written the logic, and outside the for loop we will write another if, and we'll check if count is equal to 2. If it is exactly equal to 2, I will write let us say I will write it's a prime number. Sorry, it's a prime number. Okay. So if it is if the count is not exactly equal to 2, then I can blindly say that it's not a prime number. So I will write it's not a prime number. So this is it, guys, and we are done with the program. So I'll just run it in front of you. So Java C, the file name is problem39.java. Let us compile. Okay, Java problem39, and it is saying enter the number. I will enter 2, and it says it's a prime number. Okay, let me just check for other things as well. Compile it again and run it. So let me just take 4. It's not a prime number. Correct, 4 is not a prime number. Now okay, I can run directly. So 997, so it is a prime number. 997 is a prime number, and again I will run. So let me just take 6. It's not a prime number. Okay, so you can just check out anything, guys. Okay, so 10 I will take this time. So it's not a prime number. Okay, so it's working perfectly fine, guys. And one more thing is that here you can see I'll just take another count here. Okay, so I'll just write it as LC equal to 0. That means loop count. How many times this for loop is running, I want to check, because as many times as this for loop will be running, my efficiency is going to reduce. So I don't want to reduce my efficiency. So what I'll do, I will just write here. So LC equal to LC plus 1. That means each and every time I will be incremented, the LC is also going to increment. Okay, so let me just run this thing again. Alright, so Java, first I need to compile. Okay, Java C problem 39, and after that I will run. And if I take 997, you can see it's a prime number, and one mistake what I have done, I have not printed LC. So I need to print LC as well. So I'll just copy this thing, Control C, and out of this for loop I'm going to print here. Okay, so I'm going to print LC. So that is loop count. Alright, so let me just compile this again and run this one. 997. You can see, to check whether 997 is a prime number or not, my for loop is running 997 times, which is not quite efficient. Okay, so this is not the way of writing a program properly. But guys, if you don't want to think much and if you don't want to mess up the things, then you can just simply go with this method, and it will work perfectly fine. So as the processor will be having higher speed, and you don't seem like after 2-3 seconds the output will be coming. As and when you enter, or as and when you press the enter, the output will be in front of you. But whenever you are implementing large projects, then it might affect. So there is always scope for improvement. Okay, so now I will show you what is the next method which will improve my algorithm. Okay, so Now let us concentrate on this one. Okay, so let me just take this ink. Alright guys, so here what we have seen, whenever count is equal to 2, we say that it's a prime number. Now what I will do, I know that each and every time 1 and number itself will be the prime factor of for every number. So what I can do, I will just discard these two things. I will not consider 1 and number itself. So here also I will not consider 1 and number itself. Here also I will not consider 1 and itself, and here also I will not consider 1 and number itself. So everywhere I will not consider 1 and number itself. So now my condition will be something like this. I need to erase these things, and yeah, so I will erase these things. Let me just erase this, and okay, good. So now whenever my count value is greater than 0, I will say that it's not a prime number. Because for prime number, you can see, if I'm not considering 1 and number itself, there are no factors left for the prime number. So for 3 there is no factor left, and for 5 also there is no factor left, and for 4 at least one factor is there, for 6 at least 2 factors are there. So if it's a prime number, then there will be no factors if I don't consider 1 and number itself. So if the count is greater than 0, it will not be a prime number. And if count is equal to 0, so if count double equal to 0, that means count is exactly equal to 0, at that moment I can say that it's a prime number. So before we discussed that if it is equal to 2, then we say that it's a prime number, because we have considered the 1 and number itself as the prime factors. But in second case, I can say that it's the prime number when the count is equal to 0. Here I'm not considering 1 and number itself. For this, I can just change the logic here itself. So let me just change, guys. Okay. So, and one more thing, 2 iterations will be reduced in this case, and I'm going to tell you the third method, which will reduce almost half of the iterations. But before that, you just see this one. So if n divided by I is equal to 0, count equal to count plus 1, I will keep, and I will start this loop from 2, because I don't want to consider 1, and I will be running up to n minus 1, or else I can just remove this equal to, so that it will run up to n minus 1 times, because index is starting from 0, right? So if I do these changes, then you can see I will be getting the same output, but it will be optimized by 2 iterations. So I will just run, and I will give the same number 997, and here you can see there are only 995 iterations for 997 number. That means 2 iterations have been reduced. But I know it will not make much difference for our program, but I got another method which will decrease these things to up to half of the iterations whatever it is taking right now. Okay, so this is how the second method will work, guys. And now the last and important method. So you need to observe carefully in order to understand this one, guys. Okay, so let me just okay, so I'll just erase these things. I don't know. Okay. Yes. So I'll take eraser, and I don't know how to increase this size, guys. Okay, so resize, or else what I will do, I will press Ctrl N, and I will create a new file for you. Bingo. Okay, so now let me just show you. So 4 I will take, again I will take another number 5, another number 6 I will take. So okay, so not 6. I don't want to take much examples, it will consume time. So I have taken 3 examples now. Now let me just write the factors. Here also I am not considering 1 and number itself. So 2 will be the factor, and after that it will not be having any factor. After that 5, if I don't consider 1 and number itself, then it will not have any factor. After that, here we can see for 10, if I consider, I will be having 5 will be one of its factor. Okay, so 5 will be one of its factor, and if I consider 15 also, you can see 5 is one factor, and after that 15 will be another factor, but I don't consider that one as well. Okay, so you can see if I don't consider one and number itself, and if I want to find out the factor, then for this I'm having, and out of these things only prime number is 5, guys. Okay, and for this there are 0 factors, but here the point is that how to reduce number of iterations. Okay, so if I do 4 divided by 2, what I will be getting? I will be getting 2. So just observe, guys. And for this case already we have handled this one. Okay, so don't worry about this one because it is not going to, anyhow it is handled now. So it will, if it is having 0 factors, then I will directly say that it's a prime factor. Now in case of non-prime factors or non-prime numbers, the problem is that it is taking more iterations. So if I do 10 divided by 2, I will be getting answer as 5. Okay, just observe. And 15 divided by 2 if I take, and it will be roughly how much? Okay, so 7, roughly I can say 7. Okay, so now the question is that, so this 2 is matching with this 2 and this 5 is matching with this 5, and these are somewhat somewhat they are near to each other. So the meaning is that you don't have to iterate up to the number, so you just have to iterate n divided by 2, or else I can say square root of 2 or square root of n if you iterate. So square root of n is it will be giving mostly the half or near to the half of that one. Okay, so at that moment you just need to iterate up to n divided by 2 times. Don't worry about this one square root if you don't understand. Don't worry, square root is nothing but 1 by 2, and here also what I am doing, n into 1 by 2 I am doing, guys, just like this, n into 1 divided by 2. So 1 divided by, and root value is 1 by 2, we know that. So these one and the same. Okay, so don't check up to n, so you just need to check n by 2, and if it is the same logic, just check up to n by 2 and you can see the number of iterations will be reduced. So start from 2, and after that n divided by 2, just check up to n divided by 2, and same you just need to keep it as it is. And one more thing we want to insert is, if count is greater than 0, the count is greater than 0 means it's not a prime number, right? So if it is not prime number, why the hell I should check for all other conditions? So I'll just break it here itself. Okay, so once the count increases beyond 0, that means it's going to be a not a prime number. So if it is not a prime number, definitely I will not check other conditions. Okay, so I hope you are getting the point, right? So now I'll just save this one, and let me just compile in front of you. Let us say how it will work. This time 997 I will give, and you can see it's not a prime number. Again it's giving it's not a prime number, and it is taking only 496 iterations. Okay, so it is taking only 496 iterations, and I can reduce these iterations still I can reduce with the help of square root function. So what I will do, I will write math dot sqrt, square root of whatever number is there. I will just enter that one, and rest of the conditions I will be keeping as it is. And this time if I compile and run this one, and 997 I will give, you can see it's only taking 30 iterations to decide whether 997 is a prime number or not. So this is the power of math.square root of n, guys. Just instead of putting here, okay, so you'll be putting like this, right? So n divided by 2 you'll be giving. Instead of giving this one n divided by 2, it will, n divided by 2, what it was doing, it was exactly dividing the number by 2. But if I do square root of n, then it will be somewhat near to the middle one. So beyond this square root of n, there will be no factors for a number. So due to that, I will be checking only from this line. I will be checking in this region itself, because it is the region which contains factors, and from this point, let us say it's a point A, from this point and beyond there will be no factor. So that's why there is no point in checking all those things. So that's why I am taking a condition which is running up to square root of n. So this is it, guys, and this is very important condition which will reduce the iterations. And for your kind information, I'll just show you other conditions like whether it is giving proper output for 2. Okay, so 2, it's not a prime number. So oops, 2 is a prime number. Okay, let me just see it again. Okay guys, so I have not changed the condition here, so that's why it was showing me the wrong output. So when count is equal to 0, I can say it's a prime number, and otherwise it will not be a prime number. So let me just show it again, and here you can see 2. Okay, so it's a prime number. Now again I will run this one. Okay, 997, this time you can see it's a prime number. 997 is a prime number. This time is the right output. Okay, so again 4, it's not a prime number. You can see it's not a prime number. Again I will write 8. Okay, so it's not a prime number. For 8 it is taking only one iteration. And let me just try for 12. So 12, it's not a prime number and it is taking only one iteration. So here itself it will like see guys what it will be doing. Okay, n value is 12 and it will come over here, and count it will check initially, and count I have initialized initially to 0. So it will check whether 0 is greater than 0. No, it will come inside this loop, and 12 divided by 2, whether 12 divided by 2, 12 divided by 2 is equal to 0. Yes, 12 is completely divisible by 2, so count is equal to count plus 1, means count value will be incremented by 1. Here it will come again, and I is equal to now 3, and it will check if count is greater than 0. Yes, count is holding currently 1. 1 is greater than 0. At that moment it will break out of this for loop, because if the count is not exactly equal to 0, then it's not a prime number. Then why the hell I should check for all those things? Then it will come over here, and it will check whether count is equal to 0. No, count value is 1, so it is not matching. It will not print this, it's a prime number. It will go to else loop, and it will print over here. It's a okay, so it's not a prime number. It will print because the count value is equal to 1. This is how the things will be working. And in case of prime number, like if I give 10, 20, 17 if I give, then it will be checking only up to square root of n numbers, because the factors will be lying in that range only. Okay, so that's it guys, and these are the 3 methods by which you can decide whether a particular number is prime or not. So if you want this code guys, then you can visit our website. The link for that will be in the description, and the detailed explanation will be there if you want to read it. Okay, so thank you guys, thanks for watching. See you in the next one. If you have got any doubts, then you can just comment out in the comment box. See you in the next one. Bye bye.